Yep. Okay. So now here, of course, you can see already in front of us, we have the UgCS screen. Currently, I just have an open mission with nothing in it. Well, of course, missions you can create from here. So this is where you have your new mission creation. This is where also you can open up your missions. By the way, this is something that we added in version 5 recently. Well, I mean, recently, I mean last year. And yeah, but let's get started into the flight planning part itself. And maybe actually the first thing we can go over a bit is the drone connection, because I know time and time again, we get these questions. What's the best way to connect a drone? What drone should I connect in which way? So I'll try to clear those things out a bit, sort of as the first thing on the list. So let's maybe first divide drones into I'll maybe try to do like 3 main categories, right? So there's category 1. These are DJI drones. Everything from, older drones like Phantom 4, Mavic 2 to newer like Mavic 3 Enterprise series, Matrice 4, and so on. Those I'll cover just a second. So now let's take this box, we put it here. Then next is Autel drones. With Autel drones, for whichever route you have planned, you typically now export it as a KML file into the Autel remote controller. On some newer Autel drones, you're actually able to use the same Pilot 2 format, but we will get to that. And then sort of the third category, these are drones based on Autopilot or PX4. This is going to be your free fly, inspired flight drones, and many other platforms. Most of the USA made drones that are for civilian purposes and surveying, they will be probably based on some form of Autopilot or PX4. So to connect these, typically you either have a separate radio or data link that you simply plug into UgCS, and then the drone is automatically detected. Or also, if you're using something like the HereLink controller, then you just put the HereLink controller in the same network as UgCS, and then you will be able to see that. But now let's maybe go a bit into the first category of drones. So these are DJI drones. So for DJI drones, actually, maybe it makes sense if I just share the website just for a bit instead of UgCS screen. Let me try to pull this up. Okay, there we go. We are right now on our website in the downloads sections. If you go to support and then UgCS, this is how you get here. So obviously here you have all the download links for UgCS desktop version. And if you scroll down, then you see we have currently 3 different mobile apps. So the question, which app should you use in which case to connect your drone? For DJI drones in general, there's 3 main ways how you can use them, how you can connect them. Firstly, if you have an older DJI drone, so this means everything up to the M300 and including. So with these, you can use UgCS for DJI mobile app. So here also, of course, it says the same thing. So to connect M300, Phantom 4, M600, Mavic 2 series, and others. So for these, you just need to set up this app on your remote controller, or if the drone does not have the screen inbuilt, then you can simply install it on your Android device, which connects over cable. It's now already a bit older, sort of old school way of doing that, but I know there's still guys who, when you get started, you have some Phantom 4, for example, or Mavic 2, which connects in that way. But for everyone who's already on newer DJI drones, so this is your M350, M300, Mavic 3 Enterprise, and M30. So for these, we have the newer UgCS companion app. But one thing to note is that actually the companion app is quite lightweight. So the main purpose of it is actually for users with our true terrain following kits or with SkyHub computers to be able to connect and use everything. But for normal surveys, you can also use that. Only thing to note is that, let's say if you connect something like the Mavic 3 Enterprise, you won't be able to change the camera settings. You can still see the cameras, you can see the route. On the newest version, actually, you can also even load any route for offline use. So you can just download it on the controller and then fly using the companion. And of course, also you might see here on the screen, so there's 2 different versions. So on the left, we have the version that's for the M350, M30, and Mavic 3 Enterprise. And then here on the right, we have the version for the DJI M300 drone. So this is sort of the second way, let's say, how to connect, right? So the first one is UgCS for DJI. This is for, older drones. Then for newer ones, we have the companion app. And for actually, if you're doing sort of general tasks like, LiDAR surveys, photogrammetry, and so on, you can also actually even just connect from DJI Pilot 2 to UgCS. The process there is quite simple. We also have tutorials on our YouTube on how to do that. But let's maybe quickly switch back to UgCS screen, and I'll just quickly show to you. And again, this is for those of you who are maybe just getting started, who are not that familiar, or maybe you used UgCS a while ago and now you're getting back into it. So we can press here on Add Vehicle in this corner of the screen, which, by the way, I hope, yeah, you're seeing it. And then we can click here on Connect from DJI Pilot 2. So then once you have the drone in the same network as the remote controller in your DJI Pilot 2 app, you just enter this URL. Here, actually, there are also all the instructions on the screen. And then this will automatically synchronize all the routes. So this means you can do your route planning in here, and then the routes will automatically be shown in the Cloud tab on your remote controller. So when you go into all routes, then you'll have sort of the local library tab and the Cloud tab. So in the Cloud, this is where you'll have all UgCS routes, which you can also load for offline use on the DJI's remote controller, which means that even when you don't have a connection to UgCS, you can still do that. And then one final way is that if you don't want to have this automatic route synchronization, if you don't want to do that, maybe you might not have any network through which to connect, then actually any route that you have planned, you can simply export from UgCS and import into your DJI's remote controller. So I'll just maybe quickly go over new route creation just so I can show that. So you can press here on this button to create a new route. Then here you have two options. Either you can create a route completely from scratch, or you can import it from file. The files usually are either JSON format, which is UgCS route. Then second one is KML format, and third one is CSV. So those three are typically the ones that you would use. But in this case, let's just create a new route from scratch. Let's click here on next, and then we can choose our drone. Let's maybe go with the M300. And then I'll just very quickly create some very basic route with just a few waypoints here. And yeah, then to export any route, you would go typically here and then select export option. And now you see you have three different options, either to export it as a JSON in JSON format. The second one is to export as a KML. This is if you want to take any route and then, for example, either preview it on Google Earth or use it in some other GIS software, then you can do that. Or if you just want to export it into your remote controller, then you can do this. So brief summary, specifically for DJI drone users. If you're using SkyHub, you can use the UgCS companion. Also for some other newer drones, you can also do that. If you're just doing your general surveying, mapping, photogrammetry, LiDAR, then probably the easiest one for newer drones is to simply connect from Pilot 2 to UgCS and either synchronize the routes automatically or just export the route that you need and load it onto the SD card and load into the remote controller and fly. I see there's some questions. So what are the advantages of one or the other? I mean, I'd say the easiest one is simply to have all the routes automatically synchronized. That's what I typically do. So it's just a matter of preference, really. If you mean choosing between the cloud connection and route export. So, I mean, the route file is going to be exactly the same. And yeah, by the way, once you select to export for Pilot 2 format, you'll have two options for the altitude. I recommend using this one, relative to ground under first waypoint. Simply put, this means that when you place the drone in the location where it will take off from, that the elevation or the ground level should be the same level as the ground where you have your first waypoint. So you can also make sure to place the first waypoint as close as you can to the takeoff point's location. But yeah, that's just a bit of a small note. Yeah, I see there's another question about have you upgraded the companion app for Matrice M350? Yeah, so the companion app actually it's M350 is on the main platforms that our users are right now using. Yeah, that's what you can already use with the M350. So that's at least this sort of initial overview about drone connections, and now maybe let's go a bit into some stuff related to the flight planning part. So right now I have one simple route, just 2 waypoints, and now I'll just maybe quickly delete these, and I'll just give you a bit of an overview of firstly planning photogrammetry missions, and then we'll go into LiDAR and some other applications. And if you have any questions along the way, again, just quick reminder, please make sure to put them in the Q&A session, in the Q&A section of Zoom, not the chat, because the chat I might not see the questions that you will be asking there. So anyways, now we have our route for the M300, and now let's go ahead, select the photogrammetry tool. And so in here, you can see that we can already select what camera will we be using. So we can, for instance, select the Zenmuse H20 camera. Next, we have the ground resolution parameter. So here also, of course, enter what ground resolution you want to have as the output. And then once you have all that done, then we can simply mark out some area on the map that we want to survey. Once that's done, we can hit enter. In one of the newest versions also, actually, we added the possibility to automatically calculate the direction angle, which means that whichever shape you draw on the map, UgCS will automatically determine the most optimal direction angle so that it optimizes battery use within that mission. Now here I have set a bit higher overlaps. I'll just maybe set them back to 80 and 80. Okay, so now we're looking a bit like this. Turn type I'll set to adaptive bank turn. And what else is of importance right now? So, okay, we have the ground resolution parameter, flight speed, quite obvious. 5 meters, or depending on what camera you use, you can also set this higher. And the altitude mode, currently have it set to Smart AGL. The standard one, if you have the Pro license, that's the AGL that you would be using. But Smart AGL, it works a bit better, especially when you fly over steep terrains. When you fly over hills, Smart AGL typically is going to keep a safer distance to whatever steep terrain you might have in front of you. And then here, of course, in the advanced tab, you have more settings that you can tinker with, such as the resolution of terrain following. This maybe will need to go into some more mountainous area, so I can show that to you. But here on the flat area where we are now, I can show you, for example, the overshoot and how you can set that. And that's also very simple. Here you can simply enter some overshoot parameter, and you see that these extra points are added. By the way, so by default, UgCS currently does not show the waypoints of the mission, you might notice. So it only shows the first one and the last one. So if you press on Command P or Control P, if you're on Windows computer, then you can see you can trigger these waypoints on and off. And by the way, pro tip, I guess, if you want to see more keyboard shortcuts, you can go here in the main menu and then click on the shortcuts tab, and then here you see all of the keyboard shortcuts, so you can maybe speed up your flight planning a bit. I know a lot of you probably do not know about this, so yeah, just showing this, so might be useful for some people. So that's for the overshoot. And yeah, for the overshoot, also forgot to mention, you can change the speed. So for instance, if you want to have the drone slow down as it's doing the overshoot segments, then also you can easily do that simply by modifying the overshoot speed that's set here. But for your standard photogrammetry, also what could be useful is the double grid. So for instance, if you're doing oblique scan of an area, then you can enable the double grid parameter, and then you can see how our mission looks like now. And of course, you can also adjust the angle of the camera, and this will allow you to capture oblique imagery. But regarding oblique imagery, we'll actually get to that a bit later, because also I'll show to you the new circlegrammetry tool that we have, in case you haven't seen it already. And yeah, what else? In case you need to, you can also enable additional waypoints for the photogrammetry, and this places a waypoint at every sort of location where the drone is supposed to take an image. So also this has its own use. Currently, I'll just disable it for now, but yeah, it's also just something that we offer here. And then what else? Of course, you can see here in the Actions tab that we have the Set Camera Attitude. So this changes the camera's tilt. Currently, it's set to 90 degrees. But of course, if you want to, again, do some oblique scans, some modeling, you can change this parameter. And then by default, you also have the Set Camera by Distance action. So I'll just disable the double grid, maybe also disable the overshoot, just to make the mission a bit more simple. One more thing I wanted to show in terms of route customization is that, so with UgCS, you can do a lot of different things with the routes, and you can modify them to crazy levels. So for example, we can take this one, so this photogrammetry, click here on duplicate. So now we already have sort of a similar route. We can move it just a bit here to the side. And then also if we want to, we can, for example, change this into waypoints. So if we go here and then we can select convert into waypoints. And now you can see we have a similar route, but everything is now, instead of just being one single segment, now it's waypoints, which means that we can take any of the points here in the middle of the line, we can move them around, we can even select multiple waypoints at the same time. So for example, we can click on this one and then also this one, and then we can just take this one line and we can move it a bit to the side. So you can do all these modifications. Of course, I won't show you now completely everything, but you can very easily change your routes whenever you need, and you can customize them. So that's a really good thing, I believe. So yeah, that's regarding the photogrammetry. And let's see. Yeah, okay, so I see there's already actually a question about oblique scans. So now I'll try to maybe just show that to you. So in general, how would you do an oblique mission? So, well, first option is what I was kind of already showing a bit. So with the photogrammetry tool, firstly, you can change the camera tilt here. So we can set something like 45 or 60 degrees. And also we can enable the double grid on this photogrammetry mission. And so then this is one way how you can do that. And by the way, you can also open up the elevation profile here. And then here you can see, of course, the total estimated distance, time, and things like that. But now let's maybe get into doing oblique missions. And I'll now show to you the circlegrammetry approach that we have added in UgCS last year. So let's again create a new route, and I'll create it again for the M300. Although actually, let's maybe change it up a bit. Maybe I'll select let's do the Mavic 3 Enterprise. And so now we can select the circlegrammetry tool. And now let me just mark out some location that I want to scan. So let's say this one, for example. So now we also need to select the camera. So in this case, I'll just select the wide camera. And so you can see that already over this area, it automatically creates the circlegrammetry mission. So in case you maybe haven't really encountered this yet, so what is circlegrammetry and how it's used? In general, circlegrammetry allows you to plan an oblique mission over an area where instead of the drone flying in straight lines, it flies using circles. So it flies nonstop with the camera facing towards the middle of each circle, and the camera is also, of course, set at an angle. So in this case, we can see that the camera angle is 45 degrees. From my experience, I would probably use something a bit higher. So let's say something like 60 degrees. The shots per circle are determined automatically, but things you can change is, for example, the circle size, and you can also change the circle overlap. So for example, if you wanted to fly with 50% overlap between the circles, then also you can increase it. And then if you want to bring up the route log, by the way, another pro tip, I guess, you can click here on this green checkbox, and then this shows you the route log, where, for example, in the case of circlegrammetry, we see the total area, we see number of circles, shots per circle, and the total number of images that will be taken during this mission. And yeah, you can actually change it quite a lot. You can customize it. So this means you can change the flight speed. You can change the radius of the circles. For example, let's maybe set it to 40 meters. And yep, So you can tune it the way you want. And from my experience and also our users' experiments with circle grammetry, some say that the results are similar to what you get with something like Smart Oblique, but some have also said that the results are way better because due to the I guess the nature of this type of mission, it allows you to capture a lot more different angles than your standard Smart Oblique would. So I guess I can say your mileage may vary. So this depends on the application, but I've seen also some quite good data sets that were collected specifically with the circle grammetry tool. And what's interesting is you can also cover quite a lot of area very, very quickly with this because you can set the drone to simply fly in large circles. I've also seen some guys that don't even set any overlap between circles, what was interesting. So you can just set this to 0 and you can still just do a very quick oblique scan using this method. So that's about that. And let's see what else. Yeah, there's one question also about the battery swaps. This is actually something that I think this question will get quite a lot. So how are battery swaps handled? So firstly, if you fly with DJI Pilot, then it's also quite simple. You just swap the batteries in exactly the same way. So the drone lands, then you simply swap out the battery, and then you resume the previous mission with that. If you have the drone connected directly to UgCS, then in that case, you will have actually also this. Let me just move the zoom controls a bit. So you'll see the drone telemetry panel, and then from here, when you press on upload route, so this is what you will see when you have it connected, for example, through the companion app. And then once you press on, okay, in this case, I have different drone model than the routes. That's why it's showing this message. But when you press on upload, you'll be able to either start route from the beginning, start route from some specific waypoint, or you will be able to continue the route from where the drone left off. So that's about the battery swaps. And yeah, for photogrammetry, one last thing is that also, of course, we have the corridors. So let's just again select the Mavic 3 Enterprise. And yeah, let's do corridor mapping. And the parameters are quite similar. So you also select your camera, you select your ground resolution that you want to get. And then, for example, we can mark out some very simple corridor. I'll just do it like this initially. And then, of course, you can change things such as the width of the corridor. You can change the overlap, so the forward and the side. Let's maybe actually set the ground resolution to a bit lower value so we can see multiple lines. And yeah, also, if you want to split the corridor into multiple separate routes, then at any of these points, you can select on split, and now it splits it into separate routes. And so you can do a lot of these sort of route manipulations with the UgCS because any route you can split, you can convert it into waypoints, you can combine or merge multiple routes together. And yeah, so it offers you a lot of customizability in terms of your flight plans. But okay, let's see if maybe there's already some questions that I can cover while I'm on this, and then we can probably move on. I see actually there's quite a lot that are here. I'll try to maybe answer at least some of them. So let's see. And I also have, by the way, my colleagues here, so also they'll be answering some of the questions over text. Yeah, for the if you're using the Mavic 2 Pro, then for the Mavic 2 Pro, you can use UgCS for DJI app. Oh, but yeah, so maybe just to explain a bit better. So the flight planning, no matter what drone you use, the flight planning you do on the desktop version of UgCS. And desktop, I mean, you can of course have it installed on your laptop. So guys have it on laptops, on office computers, so wherever it's more convenient for you. And then simply you connect through the mobile app. In the case of Mavic 2 Pro, this is the UgCS for DJI app, and then you can upload the route there, or you can simply save it into the local storage, and then once you're in the field, you can just fly the drone. Then, yeah, I see also another question is about 3D models generated with circle grammetry and how they compare to your standard oblique and smart oblique missions. Also, Smart Oblique, I know it depends on what drone you are using. But for example, one thing I've noticed in the case of Mavic 3 Enterprise and the Circlegrammetry is that, for example, if you need to cover sort of a limited area where you cannot really fly outside of it, the circlegrammetry is usually a better approach. That's because the way how in Pilot 2 those smart oblique missions are constructed for that drone is that it overextends it. So let's say if you have this area, basically it triples the total length in each direction when there's the smart oblique, which if you want to fly low enough to collect detailed data, it might simply not be possible. I've also faced this challenge when for example, having to scan an area that's kind of inside of, that an area surrounded by trees, then it's just simply not possible to fly low enough without risking the drone crashing into trees as it does those insanely long overshoots. So in that case, the circlegrammetry is better. And also, I've seen that from even quite limited data sets, it can capture the 3D geometry on ground better. Of course, your mileage may vary, like I said, because of the high amount of parameters that you can adjust here. But I really believe that if you tune the parameters right, then you can get better result than you can with your oblique missions from that you're simply planned on the DJI's controller. So if you push it, then you can actually get better, and you can also save on the amount of data that you collect. Yeah, another interesting question I see is that can you plan a route taking video instead of photos? And answer is yep. So you can absolutely do that. I'll just maybe try to demonstrate very quickly. We can take this photogrammetry actually as an example for that. So let's just take this one photogrammetry mission. We can see what actions we have. So we have the set camera by distance. So if I don't want to have photos taken, I can simply remove this action. And then what I can add is that in the photogrammetry, I can simply add the set camera mode and start recording action. And so this just obviously means that at the very beginning, the camera will start recording video. And you can even see it here. So when you mouse over one of the waypoints, it shows what actions is it doing here. And here it's showing it starts the video recording, and it also moves the camera down. And then if you want to also stop the video recording, then you can also set that action at a separate point. So one option is you can set it to the whole photogrammetry segment, but in GCS you can also in fact add waypoints outside of this. So for example, we can have one waypoint at the very beginning, then we have our photogrammetry, and then we can add one waypoint after it. And then simply here on the very first one, we can set the camera start recording, and then on the final point, we can add the camera stop recording, and that's it. And that's essentially how you can also record video. And okay, maybe for now, I will, yeah, let's maybe move onwards a bit because we still have quite a bit of stuff to cover. And then some other questions that I haven't yet answered, I'll try to maybe leave them for a bit later. So now let's move a bit into LiDAR, and actually maybe to make things more interesting, let's try to see if we can move to some other area, maybe something with a bit more terrain elevation changes, just so you can also see more of what GCS can do and how you can plan your missions when you're flying over more challenging terrain. So let's go here, for example, and then now let's create a new route, and now we can actually do a route for a LiDAR. So I'll select the M350 drone, and we can now select the LiDAR area. So what's different here? So in the LiDAR area, actually the distance between the lines, so the side distance, it's calculated using either the overlap and using the field of view angle of the LiDAR sensor, or it's calculated using the side distance, which means you can explicitly define how far should the lines be. It's also something which you can do with UgCS, but not with your standard Pilot 2. So then what we can do is I'll just for now leave this side overlap. So you can see the LiDAR field of view set to 70. And also in the LiDAR area, you can see that we defined flight height explicitly. So you can set it to, for example, 50 meters. and the drone will fly exactly at that height, more or less. So now let's mark out some initial area that we want to cover. Let's hit on enter and let's see if, yeah, okay, there we go. So yeah, that's at least just some very, very basic mission, just so I can show you some other things in here. So we have the field of view angle, then we have the flight height, which by the way, also we can now preview in the elevation profile. And now I think you can probably see a lot better. So how it's actually displayed over the terrain. So the camera, we can select if you have some separate camera mounted on the drone that you want to take pictures with. But I know some LiDAR sensors, they come with cameras that are working separate from the drone itself. And that case, it's not even needed. So it's not required. But in this case, you can also, for example, change the side overlap. So you can, of course, move the lines closer or further using this, or you can just define the side distance explicitly. You can also change things such as the forward overlap, and some more unique thing for the LiDAR tool is that already within the LiDAR area, you can adjust the corner radius. So you might notice that here we have somewhat squared off corners, but you can in fact increase the corner radius. Thereby, you'll now see that the corners are more smoothened out. Yeah, this means that simply the sensor will shake less as it corners. And another interesting thing is that with this, you can even do loop turns, which means that if you don't want the drone to kind of more abruptly, have to brake, then you can, for instance, define, let's say, some loop turn angle here at the end, let's say 100. And so now you can see that as the drone is flying, it does a little loop and then continues on the next path, thereby, just making the flight in general more smoother and less shaky for the sensor. In case you're using a DJI drone, you can also a DJI LiDAR. You can also enable the IMU calibration, which will add those blue parts within the route. So these calibration segments. But if you're not using an L1 or L2, then this you can just leave unchecked. And then going further, we also have the AGL tolerance parameter, and this essentially controls by how, if the terrain changes, let's say by 3 meters, as it is in this case, then UgCS will add an additional waypoint there. So using this parameter, what you can do, let's say if I set this to 10, this means that 10-meter change in the elevation is required for a waypoint to be added. And so with this, you can also control easily the number of waypoints within the mission, as well as how closely is the drone actually following the terrain. You can see the overshoot parts are still here, so you can also add them if you need to. And also for the LiDAR area specifically, we also have a parameter called the area buffer. And so what area buffer does and how it's different from overshoot. So the overshoot, it extends all the flight lines. But the area buffer, what it does is it increases the whole area. So let's say if you have this area planned over here, then you can, for instance, set the area buffer to 50, and then this will extend this in all directions to ensure that you collect the data over this whole area plus a bit extra to make sure that you don't miss out on any parts of the data. And yeah, that's actually for the LiDAR area. Those are the most important things. And one additional thing that I wanted to show you is the IMU calibration and how you add that. So here we have our LiDAR area, and then to add the IMU calibration, the figure 8, you can click here on the pattern tool, and then you can add it. I'll have to move it before the LiDAR area, since it's different from manufacturer to manufacturer. I mean, from LiDAR manufacturer, how they recommend, sorry about that, how they recommend doing the IMU calibration. Some say you have to do the figure 8 at the beginning, some say beginning and the end. So just always follow the guidelines from the manufacturer or from the distributor. Yeah, so here you can see that, oh, by the way, I'll just maybe disable the waypoints just so it's a bit more clean looking. And yep, so as you see for the pattern, you can change things such as the altitude, length, and width. And also you can change the flight speed. So for example, if you wanted to fly as, oh, sorry, it's a bit too fast. Well, it's set to 15 meters, and you can also adjust the number of passes. So for example, you can make it do 3 passes of the figure 8 pattern. So yeah, that's essentially how you do it. And since we already actually have this mission planned in sort of a more mountainous area, one additional thing I wanted to show to you is the trajectory smoothing. So this is for now still an experimental feature, which means you have to enable it from the main menu. But what this allows you to do is that if you're flying LiDAR or maybe you're flying with some magnetometer, then this allows you to have even more control over the trajectory and especially the glide slope of the drone. So let's go here in the main menu and then we go to configuration, experimental features. And so this enable trajectory smoothing in polygonal algorithms. So we can enable that, then head back. And so now if we go to our LiDAR area, and go into the advanced settings, you might notice there's now two new parameters. So there's the maximum slope and the minimal gap parameter. So what do each of them do? So firstly, the maximum slope, this adjusts the slope of the drone. So at what slope can it fly? So for example, this one, let's set, for example, 30. Essentially, the lower this value, the more it will have it will try to have control over the slope to make it less steep where it can, and vice versa. The higher, the less adjustments the slope will have from this algorithm. And also in here, you might notice that now with this enabled, that for example, for these parts, the drone doesn't waste battery moving downwards. It simply flies at the same straight line. Maybe let's just see now from this kind of side view how it looks like with 90. So you can see this sort of dip in the valley where it's going. And if you want to basically have the line as straight as you can, so you can, just go lower and lower and lower on this maximum slope parameter. And similarly, there's also the minimal gap that's here. Yeah, so with the minimal gap, you can also adjust it. And for example, let's maybe set this to 50. So with this, you can define some gaps that the drone should skip over as it is flying. So you can do 50 or 100 meters, and then based on that, you can change the length of gaps that the drone should skip on over. But yeah, that's essentially about the trajectory smoothing. Again, it's mainly intended towards LiDAR and magnetometer users, especially if you're flying over mountainous terrain, just to give you that bit more control over the flight trajectory. Okay, let's see some questions. Yeah, okay, one is, so if you use in LiDAR flight planning, if you use the buffer, can you just leave the overshoot options blank? Yeah, exactly. So you can leave any of them blank. So both the overshoot and the buffer, those are optional parameters. So for example, if you can see it now, I don't have any overshoot set, I only have the buffer. I can leave both of them completely empty, and this will be fine. There are some parameters which when you delete them, so for example here you can see that if this field is in yellow, this means this parameter is mandatory. But most fields which are blank by default, you'll see, so they are not required for calculating the flight path. All right, let's see what else is here. Yeah, and actually, another question I see is integration regarding third-party payloads. So actually, a lot of our users, they are using specifically third-party LiDARs, which simply means non-DJI LiDARs with DJI drones and UgCS. And that's because of the high degree of customizability that you can do with these routes. So essentially, any LiDAR sensor that you can put on a drone, it's compatible with UgCS because you can always create your own custom calibrations or calibrate manually. I know some prefer to automate it, some prefer to still do the manual one. Since the flight planning is based on the field of view angle, this means that any sensor can be used with UgCS. And moreover, if you have a custom camera, then in fact you can also add that. So I'll just maybe quickly go on over that. So by the way, I'll turn on to the dark mode because it's already now evening here where I am. I know for some of you it's morning, but yeah, I'll just use the dark mode to make it a bit easier on the eyes. Yeah, here in the profiles, we have the payloads section where we have all the default cameras. But if you also want to use your own camera or maybe some camera which is not in here by default, then you can just click on create new, enter the parameters of it. So weight, true focal length, sensor size and resolution, or maybe, just, you can also take any of the existing cameras. Let's say you maybe have some where, maybe you change the lens of it, then you can simply take that profile, duplicate, then you add it to the drone profile that you want to use. And this is also how you can get your own custom camera inside of UgCS. Okay, let's see any other questions that there might be, but I think that at least most of them me and my colleagues have already answered. Okay, so let's maybe jump on over to other topics that we still have to cover. And then, yeah, again, just in the meantime, if you have any questions, put them in the Q&A, not the chat, the Q&A. Sorry if I'm repeating myself, but just to make sure we can get everybody's questions answered during the webinar. Yeah, anyways, that's for the LiDAR flight planning. Then another thing is, of course, you can plan the LiDAR corridor, but maybe I won't really waste your time now on the LiDAR corridor because it's very, very similar to the photogrammetry corridor. Only thing is, of course, the parameters, they are more similar to the LiDAR area, which means in the LiDAR corridor, you still use the field of view angle. You can define the flight height explicitly and all these good things. If in case you'll want to see more about LiDAR corridor flight planning, then just let me know and I can show that to you a bit later. And by the way, also one additional flight planning tool we didn't really cover yet is the area scan. Area scan, it's very, very simple. This is sort of, it's mainly intended for people who fly with geophysical sensors. So if you fly with something like ground penetrating radar, a magnetometer, things like that, then probably you would be using the area scan tool. Because with this one, you can define exactly what should be the flight height, what should be the speed, and the side distance. So here, all the parameters are calculated. You input all the parameters yourself, and there is no overlap settings, nothing like that. So here you have more manual control than other flight planning segments that we have in here. And by the way, another really cool thing in UgCS is that you can actually combine different segments together. So maybe just to give you a very quick example, so you might have this LiDAR area that's over here. And maybe you might not be able to access there. And so you might have to fly, let's say, from this location, and you might have to send the drone all the way there. One approach to have the drone move towards the area, of course, is you can simply fly there manually and then fly that. Or you can set maybe a few waypoints. But one cool thing is that you can, in fact, use a corridor. And so using the corridor, you can just tell the drone to follow the terrain. That's I guess, the really important aspect of this is that you can fly towards any area using terrain following, collect the data there, and then fly back using terrain following. I'll just very, very quickly show to you. So with the corridor, you can set 1 point here, 1 point here, enter to complete. I'll just move the corridor to the very beginning. And okay, width is 30, so that should be fine. And yeah, so now you can see, let's also open up the elevation profile. So you can see that on the approach, the drone is following the terrain. If you want, you can also, of course, set it to fly even a bit higher. And yep, then it flies there, does the LiDAR area, and then you can also set it, of course, to return back after the mission using another corridor segment. So that's a really cool thing. You can combine different items together and build your own customized routes, and sort of any flight plan that you have in mind, you can plan that with UgCS. Okay, let's now go. Yeah, see, there's a question about, is it possible to use 2 camera profiles when, yeah, with the M350? No, you can't really use 2 camera profiles because, so whenever you have the, all the overlaps and so on, this is set using the main camera profile. So you can't, unfortunately, combine 2 of them in the same mission. But yeah, let's maybe go into some other flight plans, and then also I'll try to answer more of your questions a bit later. So let's again create a new route from scratch. Let's select the M300 drone. And now just one thing I want to cover is doing vertical scans and tower scans. So one thing which I think maybe a lot of people still don't know is that recently, well, again, when I say recently, I mean during last year, we added to our circle segment the possibility to extend it to do multiple circles. So this means that if, for example, you want to do a telecom tower inspection, then you can simply add that one circle segment, extend it to have multiple circles covering the tower, and then fly it. So I'll just try to maybe quickly create it. So I'll just put it in this location. You see I have the circle tool selected, and now I can just place it. And so this is, simply a single circular flight path. But if you want to have multiple ones, then it's very simple. You can simply change the number of laps here. So let's, for example, have 5 laps, and then you can see that there's already multiple circles in here. You can also, of course, add the camera action. By default, you only have the point of interest, meaning that the drone looks towards the center of the circle, of course. And then also you can add things such as set camera by time, where you can, for example, let's say trigger the camera every 3 seconds. You can also add the camera attitude action and change the tilt to 0. So meaning the camera will be looking towards, looking exactly towards what's in front of it. Or you can even set the angle to a bit lower, a bit higher, so you can change all of these things. And yeah, so here essentially you define the starting altitude, then the flight speed, number of laps, and then the spacing. So with the spacing parameter, you can of course change. So whether it's 5 meters between circles or 10 meters. Okay, in this case, I think it might, yeah, if the altitude is 15 meters, then of course I can't use that. Let's maybe set this to 100, just so you can see what options you have here. We can even set number of laps a bit higher. The spacing also we can, well, I think you get the point, right? So you can do alt adjustment and you can customize this the way you want to. And in fact, you can even add multiple of these circles in here. So if there's multiple towers that you want the drone to scan, you can easily do that. And for example, have it also start either from the bottom or from the top. So for example, you can see for the first circle, so the drone is starting at the very top, it's moving downwards. And then once it has reached this point, then it is moving already to the next one. And then in here, for example, we can also specify whether we want the drone to start from the bottom or start from the top. And another thing I wanted to show is the vertical scan tool. This can be useful for mining surveys or for building facade inspections. So we have it over here. And then for the vertical scan tool also, I'll just set the select the wide camera here. And let's maybe go to some clean location. And then you can also, of course, just mark out the area that you want to scan, and you can define the maximum height, minimum height here, vertical speed, horizontal one, the distance to the facade. So if it's 10 meters, 20, and so on. And also there's 2 different patterns available. So you can either use the vertical pattern, which is this one that you see right here, or also alternatively, you can use the horizontal pattern, which is better for buildings that are slightly longer. So, okay, I think then let's maybe move onwards a bit. I'll just try to show a few more things and then we can go into the Q&A session here. So this in general was sort of the overview of all the flight planning and different things you can do with that. But another interesting thing is that you can actually customize the map quite a bit that's here. So if you open up the map layers window from the top bar, and then what we have here. So firstly, you have the base map. So currently I have Google Satellite base map selected. If you want, you can switch to Bing or to any other provider. And also you can use network providers for different third-party map providers here from also external sources. Also, what's interesting is that if you have already flown over some area and you have the map of it, then you can actually import it yourself. So you can use your own maps here. You simply need to have the geotiff file of that map, so the .tif file, and you can simply load it in here and use. Similar story with the elevation. So here we have our default terrain elevation data. So the default one, the UgCS, is using its SRTM 1 arcsecond global elevation data. But you can also use your own, and you can also use even higher resolution elevation data. So if you're based in the USA, for example, you can use the UsGS site. I'm sure you're probably familiar with that. And then from there, you can get even 1/3 arcsecond or even 1 meter elevation data. And I think in most countries, you have probably some governmental services where you can get more up-to-date elevation maps and more accurate ones based on your country. But also, I know for a lot of people, just using this default SRTM data is completely okay. Another thing is that you can also import KML files in here. So if you have, for example, some borders that you want to show on the map of your GCS, also you can show this. So it can be either borders, maybe some pipelines that are going through. So all these things you can import as KML files from 2D objects. So you can just take something from Google Earth and then import it here inside of UgCS. Then also there's different place marks that you can use. So for example, at any location, if you want to, maybe mark it out somehow without having to create some route and use waypoints, you can just right click, then create a place mark here, write some description. And yep, so then you can, of course, mark it out, and it will be available there for you in case you ever need to know, okay, where is this place? And, just to be able to return to it quickly and do your flight planning there. And last but not least, there's also the possibility to load the maps for offline use. So this means if you're going somewhere where you might not have stable internet connection or the connectivity might not be the best, then you can always go here to offline maps. You can create a new map source, load the data for the map and the elevation for offline use. Yeah, let's select the geo server. You can select the elevation source and then just mark out the area that you want to cache for offline use. One single area can be in the size of up to 100 square kilometers, and you can have multiple such areas loaded. So then you can simply press here on create, and then you can see it then will cache the map and the elevation for offline use, so that will be able to use it even without any internet connectivity. So here you can also see the status and simply follow it. Okay, let's see if maybe there's some additional questions that are here. Oh, and yeah, actually, before we get into that, just one thing I forgot to show you is here in the elevation tab. One thing we recently added is the digital surface model. So what this is, typically when you plan your missions, you plan them using the terrain model, which of course, obviously is the data of the terrain, as the name implies. But if you have some data that also contains the surface, so trees, buildings, and so on, which you might not necessarily want to use for your flight planning, but it might be necessary, simply to be able to ensure that the drone will keep a safe distance to that. So then you can add it. So let's maybe I'll try to give you an example. So now let me try to upload the data. I'll see if I can find it. Just a moment. You don't see it now, but I'm just finding the folder where I have it. Okay. I think I found it. Just one moment. Need to get the geotiff file. Okay. Okay, so now I selected the geotiff file, I added it to this source, so the surface, and then in this window, you can add it either to the terrain sources or to the DSM or the surface. And so then simply once it's loaded, you can load it in here, and then basically whenever you plan a flight path there, sorry, Then in the elevation profile, you will be able to see a green line representing the surface. And so now let's move it in here. And let's focus in on this specific location. This is in Papua New Guinea, actually, where also some years ago our colleagues went on an expedition. So maybe I'll again try to just see where it is, just to make sure we are planning the flight in there. And yeah, let's go to this location. And let's just quickly create a new route over here. I'll just kind of try to speed run a bit the route creation. And let's just create something like this, for example. Okay, and so now when we go into the elevation profile, and now you will see that, so this green area, this is actually the surface part of it. So the gray area, that's the terrain, green part is the surface, and so the flight path, it's planned using the terrain, while the surface is simply there as an indicator of, how close would the drone's flight path be to the surface. But yeah, that's actually those are the main things that I wanted to cover for now. So let's maybe go a bit into the questions, and I'll see if there's some that I can try to answer right away. Okay, so one is, will the URL connection between GCS and Pilot 2 work without internet? Answer is yes. So whenever you have to connect your drone to GCS, you don't need to have internet. You can use any network as long as it allows to connect two devices. So I know that guys who go on some, serious expeditions, they usually have their own dedicated router. You can also simply have either, some mobile hotspot with you, or even mobile phone will work in most cases if the phone allows to create a hotspot without internet. So yeah, answer is, in short, you don't need to have internet to be able to connect Pilot 2 to GCS. But worst case, even if you have some issue in the field and you realize, okay, you can't really connect, you can always simply take any of your routes, you can export it into Pilot 2 format and import inside of the remote controller and fly. So there's always this backup option. Okay, let's see what else is here. Yeah, there's one question about the GCS telemetry sync tool for drone logbook. Yeah, so we'll need to update that. We have not gotten to it yet, but we'll update it to make sure that you can also still synchronize your telemetry. And by the way, since we're on this subject, I'll maybe try to quickly jump into the telemetry player, because I think probably a lot of you don't really know that it also exists in here. So all of the flights that you do while your drone is connected to GCS, the telemetry there is recorded, meaning that you can then replay any of the flights at a later time. So for example, I can add some drone here. Let's see if we can maybe add some that was also flown. Probably these are just the ones that were connected at some point, but you can see the idea. So you can select the drone, you can also move to the drone's location where it was when it was turned on. And then if the drone was sent on some route, you also will be able to sort of skip through the timeline and then sort of follow any of the actions of the drone during the flight. And also here you can see the full drone log. So you'll see things such as whenever the flight mode has been switched, etc. So, but now let's go back into the edit mode. And let's see if there's maybe some other questions that I can answer right now. Yeah, I see there's one question about thermal data processing, but no. So UgCS, it's for flight planning. For thermal data processing, you have to use some other software, unfortunately. I mean, we have UgCS Mapper software, but Mapper, it's not for thermal data specifically. So Mapper is more intended for quick map creation in the field. So with the GCS Mapper, even if, for example, one case of Mapper that I have from my own experience was back when we were in Greenland on an expedition. Also, obviously, no internet. We were in the middle of nowhere. And the map that was there, it was really, really outdated because, then all the snow around us had melted. We were basically sitting on rocks. And to be able to better understand, okay, so where's our camp? Where's the area of interest where we want to go? So then what we did was just we strapped a GoPro to the drone, but now of course you'll just be using any other drone that you can use for mapping. Mapped out the area, and then simply in Mapper we quickly processed everything and uploaded directly to UgCS. It's also one really convenient thing because when you process data in UgCS Mapper software, then from there you can just press a button and all the data is automatically loaded into UgCS desktop. Okay, what else? Let's see. Yeah, so about the projections. So essentially, for the coordinates, we use the WGS 84 system, but for the elevation, we use the EGM 96. So that's what you need to use for the elevation model. Okay, then let's see. Yeah, okay, I see also the answer about the power lines. So yeah, that's another interesting thing that you can, if you want to scan power lines in GCS, obviously you would use something like LiDAR corridor or the mapping corridor, but probably LiDAR in most cases. But if you want to see the exact height of power lines, yeah, Mike wrote that what he does is he simply exports the power lines into KML. Then this KML you can import as a place mark inside of, sorry, not place mark, but to the object inside of UgCS, and this actually allows you to see the 3D view. So it allows you to see how the line exactly goes in 3D and then plan the mission according to that. Okay, then let's see what else is here. Yeah, so some possibility to export all the flight. Okay, this is for flight details. Yeah, we don't offer possibility to export as a PDF specifically. So the export options in general, sorry, they are JSON. So both missions and routes you can export to JSON. It's KML and it's the Pilot 2 format. But actually PDF, it's an interesting suggestion. Maybe you could shoot us a message to support@UgCS.com and we can talk because I think also maybe some other pilots also would be interested in being able to export some flight details into PDF for, for example, reporting or compliance purposes. Then let's see what else. Yeah, I mean, for cyclogrammetry also, I see there's one question about can I comment for it for stockpile and volumetric measurements. I have done comparisons myself where I compared DJI's oblique scan with cyclogrammetry. For example, when testing the vertical accuracy in Nagisoft Metashape, it was basically identical. And so this means also you can use it for stockpile measurements. So if you want to just do a mission very quickly where it covers an area using the cyclogrammetry, then also I think it will be able to create quite a good result for stockpiles simply because of multiple different camera angles. I've mainly used Metashape for data processing, but I'm sure also you can probably process data similarly in DJI Terra as well. So then let's see what else is there. Oh yeah, interesting question from Hector. Yeah, so is it possible to inspect electric windmill? So is it possible to inspect wind turbines? That's a question we've been getting quite a bit, I'd say, from time to time. Even inspecting telecom towers, it's not a very simple task. And the main challenge with telecom towers is that you have to basically have the drone in the middle of the tower to be able to ensure the positioning is correct. One way how you can do that is you can fly the drone manually there, place the camera downwards, position above the tower, and then just move the mission exactly there, making sure it matches drone's current positioning. With the wind turbines, it gets even a bit more complex, but there are some ways how you can do that. So it is possible to, for example, use the vertical scan tool to be able to automate this as well. But again, the main issue is ensuring that for example, on wind turbine, obviously you have three different blades. Making a mission that surveys all three blades in different positions, it can be quite complex. But one potential solution is that you can, simply survey the central blade of the turbine, and then have the wheel rotate a bit, and then do it essentially repeat 3 different times. Again, we don't really have ready-made solution for that yet, but there are ways how, using the possibility that you can customize your missions, you can, for example, use the vertical scan tool for this. So you can just simply maybe create a square similar to this, adjust the heights how you want them to be. So for example, maximum height can be, let's say, 120, minimum can be 70. I'll just maybe change a few other parameters in here as well, and probably set the pattern to vertical one. So I'm showing just a very, very basic approach, but this is sort of what you can do if you need to, for example, construct a mission where the drone flies one line on each side of the turbine blade. So this would be somewhat similar to the mission that you can make. So the drone can, for example, start from here, move upwards as it's taking images, and then already move to the side and to the next side. The trickiest thing is ensuring that the blade is centered on a mission like this. But so the automation, ensuring the drone flies at a constant speed, so this can all be done using the vertical scan tool. But again, automating turbine inspections, it's not that simple. But I believe it can be done. Okay, so let's see what any other questions that are here. Yeah, another one that we've been getting from time to time, so thank you, Sebastian, for asking, is about possibility to do some custom LiDAR calibration patterns. We know this, we have this actually in our backlog, so it could be coming in the future. So I of course know that, yeah, for different LiDAR sensors, different manufacturers recommend different calibration procedures. I've also know, so on one hand, there's custom calibrations you can do for each of them. On the other hand, I've spoken to also some guys who manufacture the IMUs used in LiDARs. And because of course, typically the LiDAR manufacturers are very often, they don't make their own IMUs. So they buy the IMUs from somewhere. And the IMU is what needs to be calibrated. And so I've heard from IMU manufacturers that simply whatever calibration you do, as long as the sensor gets woken up and gets shaken, it's fine. It will do the job. There will not be a very significant difference whether you do a figure-8 calibration, whether you do a back and forth calibration. More or less all of them do the same thing. You can probably also use the figure-8 to calibrate, even if the sensor manufacturer says, yeah, you have to use this specific other shape. So of course, take everything I say with a bit of grain of salt, but at least that's what I know, and what I've also been talking to with the guys who make those systems. But to answer your questions, yeah, we're considering adding the possibility to add some even more sort of, I guess we can call them macros for the flight planning, so that you can easily select certain segments and then just add them in and essentially have user customized flight segments. Then let's see what other things we have in the Q&A. And can UgCS allow to set the battery to allow battery changes when the battery gets to a specified level, then return home and resume after battery change? I mean, we can't fully automate the full chain of this. What you can do, and also it depends a bit on what drone you are using. But for example, on any of the routes, if you go here into the route parameters, you can also change things such as, for example, what should the drone do in the event of loss of RC for DJI. But if you have a route that's planned for example, autopilot drones, so let's just maybe create this one as an example. So then here you can see there's more settings that you can change. So what should the drone do in the event of, let's say, battery discharge or loss of GPS? The exact battery levels, these for autopilot drones are typically set using native software. So a Mission Planner or QGC, Q Ground Control. And but here you can set, so what should the drone do? So you can simply set it to return home. If the battery gets too low, then you can replace the battery. And then once you re-upload the route from here using this button, then you can, just simply set the drone to continue from where it left off. So, okay, let's see if there's anything else I can answer right now. Yeah, I mean, I think most of the important questions I've managed to answer. In case we did not manage to answer your question, you can always send it to us to support@ugcs.com, and some of you also will probably reach out after the webinar and try to discuss in more detail your ideas and questions. But yeah, otherwise, that's it for this webinar. Hope it was useful for you and hope it was interesting. And yeah, thanks for being with us and hope to see you in the next one. So thank you so much. Have a nice day, nice evening, and bye.